this is what my plan is for today. So some days I'll be doing notes, some days you'll just be kind of working. Today is going to be more of like a notes day because there is a topic that, especially if you did not have me first semester, you didn't learn, and that's with L'Hopital's rule. And I did just want to take some time to review that. Also use the time to talk about limits as well. I think a lot of you maybe took that test, not took the test, started the review and realized maybe you have a lot of stuff you need to go back and remember, especially when it comes into limits. But right now, I am going to ask you to do kind of like a memorization quiz. So in a normal year, this would be something that's like, I put on your table, I say ready, set, go, you flip it over, and you have 10 minutes to do it. And we do these for like several days in a row until everyone starts making 100 on them. Kind of like the unit circle quizzes from pre-calc. Obviously not doing that now with people at home. Not that I don't trust people at home, but like it just doesn't have the same effect of a time quiz when people are at home. But I still want you to be able to have practice doing derivatives and limits quickly. You have to move quickly on the AP exam, and like you literally can't do most of the stuff we do if you can't find derivatives correctly and if you can't find integrals correctly. So if you have this in OneNote, where I want you to kind of look at it to kind of see the problems, if you go to that AP exam review tab, and then click on the 0 exam info tab, I know most of you just kind of write this in OneNote. Some of you might do it on a separate sheet of paper, but the problems are going to be scroll down till you're under the important stuff, and it's going to be under day 2. And then when you click on day 2, you'll scroll down, so you can kind of see I'm just reusing something from a previous year. Memorization quiz, and when you look at it, there's going to be 16 questions, and I would expect you to be able to do them accurately and correctly in 10 minutes. So that's actually how I'm going to go ahead and start off class. On your mark, get set, go. 10 minutes. It is on the AP exam info tab. Scroll down till you see AP exam review day 2. And we won't do these every day, but we'll do them probably most days until I feel like we've remembered all of the rules we should know. Because again, you can't really do calculus if you can't find derivatives or integrals quickly or accurately. But then we'll go over it, and then we'll just do a few notes just to remind ourselves about L'Hopital's rule. Yay, sensitive.
Yeah. I just like shut down, so.
about 4 minutes left and we'll go over it. Again, hopefully you're either seeing that, hey, there's definitely some stuff I know, maybe some rules you need to go back and look up, memorize. But we'll go over them in about a little less than 4 minutes and see how you did. All right, so let's go ahead and talk about these problems. Again, I chose problems that you should have been able to do quickly and really without a whole lot of thinking. Like honestly, you should be able to look at it and kind of know what the derivative or the integral is. I'm gonna go ahead and do all the derivatives first, and then we'll do the antiderivatives. First one, hopefully you realize the main rule you're using for this one is the product rule, where we have the first times the derivative of the second. The derivative of e to the x is e to the x, plus the second times the derivative of the first. And of course, that's the product rule, so that order could have been flipped, and that would have been an equivalent answer. I will say on the AP exam, they often like to simplify answers. You have like a choice A, B, C, or D. I would assume on the AP exam, they might simplify your choice as such. But again, I think most of you can kind of look at that and see that that is definitely an equivalent answer. Number 3, if you use the quotient one for this one, I can go ahead and tell you you're going to run out of time on the AP exam. Like, let's not do things the long way, let's do things the short way. So instead of doing the quotient rule, let's just bring that up with a negative exponent, and then it's going to be a really easy product rule. Exponent comes, not product, power rule. Exponent comes down in front. That 2 was already there. X minusing 1 from the exponent. Can leave your answer like that, or simplifying, negative 3. 2/4 reduces to 1/2, x to the 7/4. Looking at number 5, hopefully you don't have to think about that one. The derivative of tangent is simply secant squared. Questions on those 3? All right, hopefully you got those correct. Next 3. If students miss a derivative rule, I don't know why, maybe just because we don't use it as often, I often find students forget the derivative of a to the u. If you need the reminder, and again, there is no formula sheet on the AP exam, the derivative of a to the u is simply the natural log of the base times a to the u. So what's the derivative of 5 to the x? It's the natural log of 5 times 5 to the x. Please note it is not something ridiculous like the power rule, which is what I often see. This isn't a polynomial, this is an exponential, so it does need to use the exponential rule. Number 9, straightforward with the chain rule. The derivative of the natural log is 1 over the inside times the derivative of the inside from the chain rule. So that would be a 2x, which would simply be over the denominator. Don't cancel out those x's because you can't cancel out across a plus or a minus sign. Arc cotangent, I know if you didn't have me first semester, you didn't exactly learn these straight away, but you can think about the integral of arctangent looks like that. Arc cotangent would just be the negative version of it. Questions on those 3? All right, and then 13 and 15. The derivative of e to the u is just e to the u. This is e to the secant x, so use the chain rule. The derivative of secant is secant times tangent. And then the last one, this is one that I think is acceptable to use the quotient rule because you just have sine of x over x. So using the quotient rule, low d high, less high d low, draw a line down below, the bottom squared will go. And of course, don't cancel out any x's there because you can't cancel across plus or minus lines.
How's number 11 that? How did you get there?
Short version, that's just like the rule.
Okay.
Yeah, that's just gonna be remembered. There's no like chain rule or anything, that's just the rule. And then looking at the integrals, most of these are gonna be pretty straightforward as well. Number 2, I saw this a lot in the Unit 9 test. People just really wanted to use a natural log rule whenever they saw something in the denominator. Make sure you're careful. This one is not the natural log rule. The denominator is not raised to the first power. Add 1 to the exponent, divide by the new exponent, and don't forget plus c. Number 4, I often find people confuse the integral rule for tangent with the derivative rule for tangent. The derivative of tangent is secant squared, but the integral of tangent, and I kind of remember it because tangent comes from sine over cosine. The integral of tangent is the negative natural log of the absolute value of cosine of x plus c. So don't confuse that with the derivative of it. And again, that's just the memorized rule. Number 6, I'm going to scroll up so you can compare it to that number 7. We reminded ourselves of the derivative of a to the u. The integral of a to the u is just similar, just kind of the opposite. So instead of multiplying by the natural log of the base, you divide by it. And then, of course, you still have the plus c. Number 8, this is e to the 2x. We are going to need to do some u substitution. Many of you could probably do this in your head without writing it. U would be 2x, u prime would be 2. So 1/2, the integral of e to the u is just e to the u. Questions on any of the antiderivatives so far? All right, and then number 10 and 12. Cosecant, this is just a rule, circling it because one that people often forget. It's kind of a weird one and a long one. But the integral of cosecant, the negative natural log of cosecant of x plus cotangent of x plus c. Not a common one, but it is just a rule that you want to make sure you have memorized. Number 12, there are 2 ways to do it. I'm going to show you both ways and then which one I prefer. One method, I think of this as just 1/2 times the integral of 1 over x. I kind of like pull that 1/2 on the outside since it's a coefficient. If you do it that way, you get 1/2 the natural log of the absolute value of x plus c. That's my preferred answer. The other way to do it, though, is you could just let u be 2x and u prime would be 2. So you would still have that 1/2 plus the natural log of the absolute value of u plus c. I know many of you look at that and you're like, okay, well, one's the natural log of x and the other one's natural log of 2x. Those definitely aren't the same. And short answer is they actually are the same, they just have different constants. One's plus c is a different plus c. The reason why they're the same, the natural log of 2x just in general is the same thing as saying the natural log of 2 plus the natural log of x. That natural log of 2 is just a constant, whereas that in that first example is just hiding somewhere in that plus c. So they are the same. I prefer the first one, I think it looks nicer, but they're both the same. If it was multiple choice, only one of them would be an answer there, but hopefully you can at least match it up to whichever one you got. 14, I hope no one missed. The integral of sine is just negative cosine of x plus c. The derivative of cosine is negative sine. And then 16, one of the versions of the Unite test had that antiderivative. I think it was in terms of a y instead of x. I saw a lot of people force that as a natural log. A lot of people wrote that with like a negative exponent. The difference of the degrees is more than 1, so we hopefully recognize that as an inverse trig rule. Which version of it is it? That is an arc sine rule. So I have x over the a value, which is 3 plus c. So looking at those 16 questions, like if you missed 1 or 2, you're good to go. If you're missing like half of them, more than half of them, even like 4 of them, then I can jump to some rules if you want to go back and review. Again, I'm not going to do one of those every day, but just kind of like every few days while we're reviewing. We'll just do them, not like I'm taking it for a grade, but it's helpful to review those rules, to do those rules quickly, because ultimately you can't do anything in calculus if you can't have a correct derivative or a correct antiderivative or integral. So what I want to do for a little bit today, I know there's not tons of time, but I did want to give you some time to work on some stuff. But I did just want to do some very, very brief note on L'Hopital's rule. Now, those of you who had me first semester, we learned it. You might need to review it, but we did learn it. But I'm teaching this one because if you didn't have me, I know it was not taught in GABS. And number 2, it will allow me to kind of review limits at the same time, which I do know it has been a while since we've looked at limits. Many of you haven't really looked in depth about limits since August, so it is definitely something that we can review. So my goal is, what time is it? 2:59. I will stop by, we'll say 3:15 if not sooner. And that whatever we don't finish, we'll just carry on tomorrow. I'm not pressed for time if I don't finish, because I'd rather do things well than do them quickly. If you want to follow along with notes, they're going to be posted under the day 2 kind of stuff. So, L'Hopital's rule, I'm just going to teach it like no one knows what that means. It is basically a way to take limits when you have the indeterminate case. Named after a mathematician, his last name was L'Hopital, which literally means the hospital, full last name I guess. But that is basically what we're looking at. To remind you, and I think what is going to be very useful to a lot of you, is we know that when we're taking limits, like a lot of things can happen. Sometimes it's a known value, sometimes it's an unknown value. So in this box, I have 9 different things that show up commonly when you take a limit. Now, normally when you take a limit, the thing that you want to do is you just plug it in. Like if I say, what's the limit as x goes to 2, just plug in 2. What's the limit as x goes to 3, plug in 3. If you get a number, great, that's your answer. But this is AP calculus, so often you don't get a number, so you have to figure out what the actual answer is. So these are kind of like the 9 different options that show up a lot that aren't just a number. Some of them are pretty easy. Like if you get a 0 divided by a number, what is that limit going to be? 0. What about if you have a number divided by 0, what is that going to be? Undefined. So the limit we would say is D and E. What about if we have a limit that becomes 0 over 0? What will we say that one's going to become? Keep going. So 0, 0 means nothing in math. It's an indeterminate form. We want to keep going. Moving on to that second row, what if you have infinity over a number? What are we going to say that limit's going to be? Infinity. What do we say a limit going to infinity is going to be? D and E. So remember, if it's growing without bounds, it's just D and E. The limit is not existent. What about if that infinity is in the denominator? What are we going to do? 0. Big denominator, that limit's going to 0. If we are going and get infinity over infinity, there's two main methods we did first semester that can help you approach an infinity over infinity. What matters most? So like you have multiple terms, circle the part that matters most at infinity, what's the biggest, and then simplify. Or if you have like multiple things going on, there's also factorial, which we don't really have in AP calculus, but exponential, polynomial, and log. The first ones are going to be the bigger infinities going down to smaller infinities. So like exponentials are bigger than polynomials, which are bigger than logs. And then this last row, what's going to be 0 times anything? 0, and I should be clear, 0 times a number is 0. What about infinity times a number? Infinity, we would say the limit is D and E. What about something approaching 0 times infinity? What does that mean in math? Keep going, yes. So that's going to be a keep going. I'm glad there was the pause there. That will also be a keep going. Some weird things can happen in limits when you say 0 times infinity. Because often, when I say 0 times infinity, it might be like 0 times undefined as well. Because we know that where can infinity show up at? Infinities can show up when you're approaching like an asymptote. And often when you have that one, you want to force it to look like 0 over 0 and approach it differently. When we said keep going, there are several methods we used. We had factor and cancel. We had rationalizing and canceling. And then maybe we just had like, let's just do some algebra to simplify it and hope things work out from there. The fourth method that we have when we have a 0 over 0 is going to be this formula called L'Hopital's rule. And that's why I just want to kind of give you a formula for, especially for those of you who did not have any first semester. And what L'Hopital rule states is, his rule states, if after you do direct substitution, you get 0 over 0 or infinity over infinity, and only 0 over 0 and infinity over infinity, then your limit as x goes to c of a numerator divided by the denominator is the same thing as saying the limit as x goes to that same value of the derivative of the numerator divided by the derivative of the denominator. It is super clear. It only works if direct substitution, to be clear, only yields that. So like if you do direct substitution, you get a number, that's the answer. Don't do L'Hopital's rule, you're going to end up with the incorrect answer. So let's just kind of look at an example, looking at time. I'm making good time. Here is the example I want to look at. I did share this with you. That's the flow chart from first semester, just in case you wanted a reminder of it or needed to look at it. But let's look at this example. So we have the limit as x is going to 0. Whenever you have a limit, what's the first thing you always want to do? Plug it in. And one thing I want you to get used to on the AP exam, use arrows drawing out from your numerator and the denominator, especially on a free response question, because that just makes College Board happy. So like, don't use equal signs, just use the arrows. I'll explain why in a second, but use the arrows. So let's plug it in. We're going to have the sign of 3 times 0. So that's going to be the sign of 0, which is 0, minus 2 times 0, which is 0. So we have 0. And then the denominator is x. Plugging in for 0, we have 0. So I have 0 over 0, so I can run through my options. Can I factor that? No. Can I rationalize it? They're not really radical there, no. Can I simplify it anyway? No, definitely can't cancel out any of those x's. So our only option is to use L'Hopital's rule. 0 over 0 is never an answer. L'Hopital rule states, when you take the limit, separately take the derivative of the numerator, take the derivative of the denominator, and then plug it in. Derivative of the numerator. The derivative of sine is cosine. Leave the inside the same. Chain rule. The derivative of 3x is 3. Minus the derivative of 2x, which is 2. The derivative of x, which is 1. Simplifying it, now we can go ahead and plug it in. That's going to become the cosine of 0, which is 1. So we just have 3 minus 2. The limit to this is 1. So L'Hopital's rule save the day. We're able to find that limit now and take care of what we call that indeterminate form. On the AP exam, you always have to show it, unless it's multiple choice, you have to show that you have 0 over 0 before you jump into L'Hopital's rule. To show that, you always want to do kind of what I highlighted. Draw your arrow 0, draw your arrow 0. College Board, someone up in College Board who thinks they're important has decided that writing something like this is apparently like the worst thing in the world. I have lots of opinions about that myself, but College Board like melts when you write that. So just use 2 arrows and show 0 over 0. Trust me, just do it that way and you'll be good. Let's do one more slide and then that's where I'm going to stop at today. I'm going to skip to examples. Here's one question, and I like doing this one because it shows you that, like, clearly L'Hopital's rule is not the only way to do limits, but it is just another kind of tool that you can use. First step, whenever you see a limit, you always want to just do direct substitution. So again, I'm going to do my 2 arrows. Let's make College Board happy. 6 squared, so that's 36, minus 42 plus 6, 0. 6 minus 6, also 0. Whenever we have 0 over 0, that tells you to keep going. Let's use L'Hopital's rule method first. That's going to be the newer one. I like it better. It works. L'Hopital rule states, hey, take the limit. If you get 0 over 0, take the derivative of the numerator. Take the derivative of the denominator, and then just plug it in. So, with my derivatives, plugging it in, 2 times 6 minus 7, that's 12 minus 7, giving you the limit of 5. Didn't have to do L'Hopital's rule. What's the other way you could have done that problem? Factor and cancel. Some of you might have preferred that way. If you were going to factor and cancel, we'll see we get the same answer. Denominator is x minus 6 still. 2 numbers that multiply to give me positive 6, but add to give me 7. Negative 6 and negative 1. Factored, cancel. Canceling out what gave me 0 over 0. Now doing direct substitution. 6 minus 1 is equal to 5. Both are valid, both are correct. I like L'Hopital's rule because it does work in cases where you can't factor, and L'Hopital's rule will always work whenever you do get 0 over 0. I do have a few more problems I want to do with L'Hopital's rule, but I'm going to hold myself to the time, and we'll just do those tomorrow. Again, I'm not really in a rush to just cram stuff down. Assignment-wise, again, things that I want you to work on. At this point, I really just want you to focus on multiple choice pages A, B, C, and D. And again, I would recommend, like I know some of you are like, Mr. Brown, I want to be ready for the exam, let me just do all the questions. Just do like 5 on each page for now, and then once you practice all the topics, then go back and do the ones that you maybe skipped over. But like at a minimum, 5 questions from each page, and then all the free response questions. So tomorrow we'll just do more L'Hopital's rule. I have a free response kind of picked out, and we'll just keep trucking along until May 4th. So yeah, y'all can go ahead and get started. If you have questions while you've been working, like ask them now.